Solving systems of linear inequalities. In the past, we've done just one linear inequality where we graph one linear equality. Well, when we're talking about systems of linear inequalities, we're talking about two or more linear inequalities. And linear means line. And then inequality, that just means not equal, but instead of writing an equation, instead of writing an equation with an equal sign, an inequality is going to either be greater than, less than, greater than or equal to, or less than or equal to. And that's what we're talking about when we say inequalities rather than an equation. So we're talking about a line that's also an inequality. So let's just jump right in and see an example, and you may see a little bit clearer what I'm talking about here. If we want to graph the system y is less than 2, that's our first inequality, and then the second one is y is greater than x minus 2. Okay, what we're actually going to do, we want to graph this. We're going to graph it. But what we're actually going to do is graph the line y equals 2, and we're also going to graph the line y is greater than x minus 2. That's our starting point. We're going to graph those two lines, and then you'll see how the inequality, then we'll tackle how the inequality affects our graph. So to graph those lines, first we'll need our x and y axis. And let's take a look at this. Y is less than 2. Well, we're going to graph this one, y equals 2. Well, where does y equal 2? Well, y equals 2 at any point. It doesn't matter what x is, but it's any point where y equals 2. So we have all these points. So if here's 1, 2, 3, 4, y is going to equal to 2 anywhere on this horizontal line. And I'll change the color. So if you pick any point on this line, y is going to equal 2. For example, when x equals 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When x is 10, this is 10, then on this line, y would equal 2. So when x is 10, y would equal 2. And when x is 0, y also equals 2. So we graph that line, y equals 2, and now we're ready to look at the inequality, which is less than. Y is less than 2. Y is less than 2. So what that means is that, well, y can't equal 2, like we're showing in this line. Y is the solution is going to be any value where y is less than 2. So to show that, we're going to make this line a dotted line. And we're making it a dotted line to show that it can't equal 2, that y does not equal 2, y is less than 2. So we'll make a dotted line showing that it can't be on that line, but that's kind of our boundary. And we want to shade in everything where y is less than 2. Well, that's everything below this line. So we can shade in, and I'm just going to draw lines, but anywhere where there's these lines is going to be where y is less than 2. Okay, so we graphed the first inequality where y is less than 2. Now let's look at the second one. Y is greater than x minus 2. Okay, now this one, we're going to graph the line y whoops, I wrote that wrong. Y equals, we're going to graph this line. Let me erase that so it looks a little bit better. We're going to graph y equals x minus 2. And this, you'll notice, is already in the slope-intercept form, which is y equals mx plus b, where m is the slope, and in that case, m is 1. You can imagine an invisible 1 in front of that x. So m is 1, and b, which is the y-intercept, is negative 2. So b is negative 2. So b is where it crosses the y-axis, and just a reminder, this is the y-axis, and this other one is the x-axis. And it's going to cross at where b is negative 2. And let me change the color so you can see it a little bit better when I draw it in there. So there's negative 1, here's negative 2. So b is negative 2. So that's where the line crosses the y-axis. Now look back at the inequality. It's greater than. It's not greater than or equal to, which is significant because since it's just greater than, when we draw our line, we're also going to use a dotted line like the first one. If it was greater than or equal to, we would use a solid line. But in this case, it's going to be dotted. And using our slope, which is 1, you can also write that as 1 over 1. So you can think of rise over run. We're going to start at the y-intercept, and we're going to use our rise 1 and run 1. Rise 1 and run 1. And now we can draw our line, which is going to look something like that. So it goes through those dots, and it's dotted. Okay, that's our boundary. Now let's take a look at the inequality. It's going to be everything where y is greater than x minus 2. And to decide which side of this line to shade in on, we can put in a point, we can plug in a point that's not on the line. And if it's not on the line and it ends up being true, if it ends up resulting in a true statement, we shade in on that side, wherever that point is. If it ends up being not true, then we shade in on the opposite side of that point. So an easy point to do would be 0, 0. 0, 0 is not on the line. 0, 0 is not on the line. So if we plug in 0 for x and 0 for y, we get 0 is greater than 0 minus 2, which is negative 2. And that's a true statement. 0 is greater than negative 2, which means that 0, 0 is part of our solution, which also means that that's the right side of the line to shade in on. So we'll shade in everything on that same side of the line. So it's everything above that line. It's everything where y is going to be greater than x minus 2. Okay, so this is starting to look a little messy, but our solution to both of these, to the system of linear inequalities, is the area where both areas are shaded. So it's going to be the area where they overlap. So it's going to be greater than this one. It looks like a green, like a sea green type color. And then it's going to be everything less than this yellow line. So it's where they overlap, and I'll show that in pink. So our solution is all of this area. Okay, I hope this is starting to make a little bit of sense. I know it looks kind of complicated and kind of messy here. In the next video, we'll show one more example of this, and by then you should start getting the hang of solving systems of linear inequalities.